Okay, Trig, this is day 2 of review. We're starting with 16. I'm going to try to get to like at least 30. And some of these problems do take a little bit of time, so hopefully this isn't a terribly long video. Goodness, that sounds terrible. Okay. All right. Let's just jump right into 16. Simplify. So one thing that I notice is that we have a square root on the top and a square root on the bottom. And that means that I can put them all underneath of one square root. And by doing that, then I can reduce all of these things in here, like the 8/4, the C's and the D's, right? And then worry about the square root later. So looking at the numbers, I'd take those individually. 8 and 4 reduce it. Don't forget my square root. 8 and 4 reduces to 2 and 1. So I'm just going to do 2 and 1. You don't have to put the 1 there, but that's what 8 and 4 will become. Okay. For C's, I have 2 on top and 12 on bottom. So that means I'm going to have 10 on bottom. And then as far as D's go, I have 7 on top and 3 on bottom, which means I'm going to have 4 on top. Okay, that's like subtracting those. Okay. All right, now the only other thing that I need to do is look at each piece individually. So like if I would break these apart, like the square root of 2 and the square root of D to the 4th and the square root of C to the 10th, like what would that look like? Okay, the square root of 2 is not going to break down, so I'm just going to leave him as the square root of 2. The square root of D to the 4th is D squared, okay? But what I'm going to do is I'm going to put the D squared in front of the square root of 2. Typically, I like to put the numbers on the outside in the front and the numbers on the inside trapped underneath. The square root of C to the 10th power. A lot of people get confused about that because they're like, you can't take the square root of 10. Well, what you're doing is you're saying, what do I take times itself to get C to the 10th power? And that is C to the 5th. When you're doing exponents, you're actually dividing by 2. You're not taking the square root of 10, you're dividing the exponent by 2, because C to the 5th times C to the 5th will give you C to the 10th. You're adding those together, okay? So that's how that works. And I think that's it. There's nothing else that we can do for that, okay? So that's completely reduced. Next one, number 17. We want to rationalize, and I think we already did a rationalize one yesterday with i's, but the thing that I have a problem with is having a square root in the bottom. So we want to get him out by multiplying by the conjugate. Okay, the conjugate of 6 plus the square root of 3 is 6 minus the square root of 3, but if I do it to the bottom, I've got to do it to the top as well. Okay, and then we're just going to do a bunch of FOIL stuff, okay? So 1 times 6 is 6. 1 times negative square root of 3 is negative square root of 3. Square root of 5 times 6 is 6 square roots of 5. And then the square root of 5 times negative square root of 3 is negative square root of 15. Okay, so hopefully that made sense. All right, the bottom, 6 times 6 is 36. I'm going to write out all my work. 6 times negative square root of 3 is negative 6 square roots of 3. But then this is plus 6 square roots of 3, so those are going to cancel. And then the square root of 3 times negative square root of 3 is negative square root of 9, or just 3, right? The square root of 3 times the square root of 3 just pops out as 3. So you will notice that these two cancel with each other, and then I can combine the 36 and the 3, or the minus 3. So he is 33 on the bottom, and then none of these terms on the top, there's 4 of them, none of them will combine. So my top is like all of that, 6 minus the square root of 3 plus 6 square roots of 5. It's hard to know what order to go in. Like, you typically want to go, like, put them in order, like descending order of the variable, whatever. But, like, those don't really have an order. So if you would put them in the wrong order, they're technically not wrong. So that is that. That was kind of messy, but our ultimate goal was to get no square roots in the bottom, and I have achieved that. Okay, if you end up doing a problem like this and you still end up with a square root in the bottom, you did something wrong. Okay, all right, they want us to simplify without using a calculator. I can multiply two numbers together if they're not the same. Like I could take 3 times 48. But when you're adding and subtracting, I can only put them together if they are like terms, which means either both of them have to be square roots of 3 or both of them have to be square roots of 48. So I'm going to guess that 48 breaks down, and if I was a betting person, I'm going to say we end up with 3 left over underneath of the square root, so he will combine with this one. And 48 divided by 3 is 16, so that does end up nicely. So the square root of 48, the square root of 16 is 4 square roots of 3. So the square root of 48 became 4 square roots of 3. So now I have 11 square roots of 3 minus 4 square roots of 3. And since my bases are the same, this I can just do 7 square roots of 3, and that's what he will become. So, man, oh man. Okay, all right, so that was 18. Keep a moving. All right, this looks kind of intimidating. Whew. All right, so I've got tops and bottoms. I've got x's and y's on tops and bottoms, so we're going to have to combine those. But the very, very first thing I'm going to do is address these parentheses in this exponent. So I have to distribute through. And the main thing that happens when people are distributing this 2 through, they forget to square this 2. Don't forget to distribute the 2 to the 2 in front, okay? You don't do it to just the exponents. So 2 squared is 4. Then your x becomes x to the, do I multiply or do I add? Does this become 6 or does it become 5? So I always think about, okay, if it's x to the third squared versus x to the third times x squared, which one is multiply, which one is add? This one is 6, this one is 5. So because I'm doing like the stair step thing, I'm doing this process. So this is x to the 6th power, okay? The y will be to the negative 6th power. And then on the bottom, I've got 6, x negative 3, y 5. All right, now I got to put stuff together, okay? So I'm going to worry about the numbers first. 6 and 4, both of those will divide by 2, so 2 and 3. Okay, then I want to fix any negative exponents. So this x to the negative third is going to come to the top, and he's going to become x to the positive third. Then I can combine these two, and those are like this problem, where they're right next to each other, and that means I add them. So that's x to the 9th power there, okay? Now I'm going to go to y's. I want to fix this negative 6th power, so I bump him to the bottom, and he becomes positive 6th power. Then these two will add, so that's y to the 11th power, and that is my final answer. Okay, so negative exponents, you flip them. If they're on the top, you flip them to the bottom, that type of thing, okay? All right, that was 19. Let's do 20. Solve the following equation. All right, here's my equal sign. I'm going to keep track of where that's at, and then I'm subtracting. First thing I do is plus minus. I distribute him to the top. Okay, we need to find a common denominator because we are adding and subtracting. So the first thing I'm going to do is, this is a trinomial. If I break him down, I want to multiply to get negative 12, but when I add them, give me negative 1, okay? So I'm going to say x minus 4 and x plus 3. And coincidentally, x minus 4, x plus 3. Take a look at that. That's so exciting. All right, I've got this guy plus this guy equals this guy. All right? And if I find my common denominator, going through here, I know I need an x minus 4, so I'm going to list it. I know I need an x plus 3, so I'm going to list it. I know I need an x minus 4, but I don't need 2 of them. And I know I need an x plus 3, but I don't need 2 of them. So that's my common denominator going through here. X minus 4, x plus 3. Some of you guys skip this step and you don't write it out, which is totally fine because he's going to cancel as soon as we get the tops and stuff figured out, okay? So I've got minus 14, minus 1, and 2, and we have to multiply by what he needs. So I got to figure out what he needs on each one of these. Okay. So if I'm looking at the bottom of my 14, he has both of these pieces. So he doesn't need anything. You can put a 1 here if you want to, or you don't have to multiply by anything because he's not missing anything. But this guy is missing an x plus 3, so I have to multiply him by x plus 3. This guy is missing an x minus 4, so I'm going to multiply him by x minus 4. Then my bottom cancels. And then I'm just going to solve. So I'm going to put this stuff over here. I have negative 4 times 1, or negative 14 times 1, which is negative 14. I have to distribute my minus 1 through. So minus 1x minus 3 equals, and then distribute my 2 through. So 2x minus 8. If I'm going too fast, please pause. Okay. I'm going to now solve some stuff. Okay, so I'm going to combine my minus 14 minus 3. That is minus 17. I'm going to add the 1x over. So I get negative 17 equals 3x minus 8. I'm going to add the 8 over. I don't know why I'm writing in black. I have no idea. Sometimes I just pick random colors. Negative 17 plus 8 is negative 9. And if I divide by 3, x equals negative 3. All right, hold up before we call it quits. We look at our original problem, and these were our denominators. And really, this guy is those two together. So we look and say, what can x not be? If x minus 4 can't be 0, then x can't be 4, right? And if x plus 3, we don't want that denominator to be 0, so x can't be negative 3. But wait a second, that's what I got as an answer. X is negative 3. So what's my answer? This can't be an answer, so I have no solutions to this. There's nothing that I can plug in for x for this side to be equal, for this side to be equal to this side. That does not work. Because I'm not allowed to plug in negative 3. Okay? So that was kind of a pain in the butt. We got all the way through and we didn't get an answer. Whatever. All right. Not always. I mean, most of the time you will get an answer. If you sometimes you'll get 2 answers, but one of them won't work. So it'll just be the other one as an answer. Whatever. Okay? All right. Write the equation of the following circle. All right. We really struggled with circle equations. Here's the equation for a circle. X minus h squared plus y minus k squared equals r squared. Okay? Your center of your circle is hk, and the radius is r. Okay, there is that. All right, so we have already what the center of the circle is. It's 2, 4. 2, 4. So all I need to do is plop it in here. And that does change it to a minus 2, and this does change it to a minus 4. Okay, so it's the opposite sign in the parentheses as what it is on the thing. Now we have to find the radius, and they don't list that. So we have to do the distance formula. Okay, distance formula is going to be the square root of all that junk. This is what distance formula looks like. My geometry kids are like, oh, great, another one, right? We got to do this a whole bunch in our geometry test. Okay, the distance from negative 2 to positive 2 is 4. The distance from 1 to 4 is 3. Oh, that's so nice. 4 squared is 16. 3 squared is 9. 16 and 9 is 25, which is 5. Hey, my radius is 5. Okay, so when I go to write my equation, I put 5 in there. So final answer, I'm just going to clean them up a little bit. X minus 2 squared plus y minus 4 squared equals 25. There we go. Perfect. Okay, that's the equation of a circle. All right, identify whether or not the following set represents a function. It is a function if the x does not repeat. It's a function if it passes the vertical line test. So like if you have a graph, you don't have to write this down, but if you have a graph and you have 2 dots that are right above each other, they will have the same x coordinate, which means they won't pass the vertical line test. Haha, that's why, right? So I cannot have my x's repeat. 2, 3, 4, 5, 6. We're good. Yeah, so yes, he's a function. Perfect. Okay, that was nice. 23, find the domain. All right. Domain. When you're doing domain, you worry about a negative inside of a square root, and number 2 is dividing by 0, okay? Out of these two, the easier one to do is the bottom one. This one is a little bit harder to figure out, okay? So dividing by 0, it's easy to figure out what that number is. So like if I look at this, this one actually has both problems going on. Yikes. So here what I have is I know that t cannot be equal to 3, because if it is, then we would end up dividing by 0. Okay, so I can't have that, all right? Then I look at the square root on the top, and this is a little bit harder to do. Some of you guys can figure this out in your head, but if you can't, that's fine. Basically what happens is if this number is 2, it's kind of like solving the bottom one. If this number is 2, I would end up with 0 in here, okay? If this number was a number bigger than 2, I would end up taking the square root of a positive number, which is fine. But if this number is a number that's less than 2, like 1 minus 2, that'll be a negative, and I cannot have that. So like basically what I just did was I know 2 is my critical number. My calc kids, critical numbers. We also talked about them in trig just recently. Critical number of 2. I cannot have numbers that are smaller than 2, like 1, because I end up with a negative inside of my square root. But I can have this going on, right? So we would say for a domain is that x has to be greater than or equal to. I can plug 2 in and have 2 minus 2. I can take the square root of 0. That's fine. So x has to be greater than or equal to 2, but x can't be 3. And I just changed my variable from t to x. Whatever. I don't care. Okay, so at 3, I have like an open circle, so I can't have that, but x has to be bigger than 2 because I can't plug in numbers smaller than 2. So that was kind of like 2 domain issues going on at the same time, and trying to coordinate them. That was actually a little bit of a hard problem. Okay, so that might be one that like maybe you star if that didn't make any sense, and I can come back to it and explain it tomorrow. Okay? There is that. That was 23. Write the, oh, this is nice. Now we get to the easy stuff, okay? Here we go. And my geometry kids are like, oh, more of this? Come on. Or maybe you're excited about that. I don't know. It's less to have to study. Write an equation in slope-intercept form. That is y equals mx plus b of a line that passes through those 2 points. All right. I think this might even be the exact same problem I used for geometry. I don't remember. All right. The first thing I need to do is find m. Okay, so m is y2 minus y1, x2 minus x1. So 5 minus 2 over 2 minus a negative 4. That's like 2 plus 4. So this is 3 over 6, and that is 1/2. Yeah. Y equals 1/2 x plus b. Now to find b, I either plug one of these two in. So I'm going to plug in 2, 5, because I don't like negatives. So 5 is going to go here. 2 is going to go there. And then half of 2 is 1. And if I subtract 1, the b value is 4. So y equals 1/2 x plus 4. That's my equation of my line. Okay, I did that super fast. So if you need to pause and go back to write stuff down, you go for it. Okay? All right, this one is talking about a perpendicular line, and I don't remember on the test if I do perpendicular or if I do parallel, so we're going to talk about both. Parallel versus perpendicular, okay? If 2 lines are parallel, they have the same slope. And my geometry kids are like, I wrote this down like twice in my other packet. Perpendicular is negative reciprocal slope. Okay, so this is my original one. This is the original guy, and if I'm trying to find the slope of my original guy, that is 1/3. I'm just picking it out of here, okay? So if I'm looking for a parallel line, 1/3 slope is going to stay 1/3. But if I'm looking for perpendicular, 1/3 is going to be negative reciprocal. Negative, and 1/3 is going to flip to 3 over 1, or just -3 is going to be my new slope. Okay, now if it's already negative, you make it positive, right? Negative reciprocal, you undo the negative. Okay, so my new slope, I'm going to call him m new, is -3. Okay, now all I have to do for y equals -3x plus b is solve for b. Okay, and I use this point to solve for b. -2 over here gets thrown into a hole, and we don't use him ever. Okay, that b value does not get used at all, at all. 6 is my y coordinate. -1 is my x coordinate. So this becomes +3, and I'm going to subtract 3 to get him to the other side. So b is 3, and then I'm going to throw it all together. So I have y equals -3x plus 3, and that is my line that is perpendicular to that one. Maybe that wasn't in my algebra class. Maybe that wasn't in my geometry class, but I know I've done that exact problem again. Okay, all right. Determine whether the lines are parallel, perpendicular, or neither. This problem might have been in my geometry class. I don't know. I know I've done some of these problems already before. Okay, we need to, first and foremost, before we do parallel, perpendicular, and neither. By the way, I'm just going to put an arrow to this because we're going to use those rules for parallel, perpendicular, and neither. We need to solve for y. We need to get him in slope-intercept form. So if I solve for y, you guys are big kids, I'm going to kick this and this to the other side at the same time. If this was an algebra class, I would do this slower. But I'm going to kick those both to the same side, to the other side. 2x, if I kick them to the other side, is going to be negative 2x. Minus 2 is going to become plus 2. So that's my first one. All right. Now I'm solving for y here, but I'm going to get 2y by itself. If I kick these to the other side, they will be negative 4x minus 18. Okay. I'm going to move those both at the same time. Then I divide by 2. So y equals negative 2x minus 9. So I'm comparing these two together. And to determine whether they're parallel, perpendicular, or neither, this guy's slope is negative 2. This guy's slope is also negative 2. Hey, that means they are parallel. Okay, they have the same slope. All right. Now, if they have the same y-intercept, like if this was minus 2 plus 2, those would be exactly the same line, right? They wouldn't be parallel. But they are parallel because they have the same slope. In order to be perpendicular, if this one was negative 2, this would have to be positive 1/2. But that is not the case, so they are parallel. Okay, I'm already really feel like I'm going over time, but whatever. 27 will be a little bit faster. They want us to find f of 0, so we're plugging 0 in. We have two equations that we could plug it into, right? So what I want to determine is I look at this to tell which equation I'm going to plug into. I'm plugging 0 in. So do I plug 0 into the top one, or do I plug 0 into the bottom one? Okay, 0, it's equal to 0 for the top one, but it is only greater than 0 for the bottom one. So I don't want to use the bottom one. I want to plug them into the top one. So all I do is plug 0 in here, and 0 plus 5 gives me 5. So I say f of 0 equals 5, and that is my final answer. Okay, so you just use this. This is called the domain. You use that to figure out which equation you're going to plug into, and then just plug it into that one, and you're good. Okay. All right, this one, 28, says find f of negative 3. Negative 3 is like my x coordinate, and f of x is like saying find the y coordinate, right? So negative 3, negative 1, 2, 3, negative 3. I want to know where he hits my graph. 1, 2, 3, negative 3. Negative 3 isn't negative 3. He's down here on this graph. So there you go. Negative 3. I'm just figuring out where he hits on the graph. If there was an open circle there, that would not be the case. Like negative, if I said find f of negative 4, you're like, oh crap, is it this one or is it this one? Because those are both touching negative 4, but this one's not touching because he's an open circle, right? So answer is just negative 3. That wasn't too bad. Okay. All right, 29. Oh, good heavens. Why'd I have to give you this one today? Okay. All right. They're asking for, we're starting with our parent function as the absolute value, and I want to horizontally compress by a factor of 2, reflect across the x-axis, and shift 3 units up. And I'm going to do all three of those things and write a new equation. Okay. If you want this, I would write this off to the side over here. Let's say for now our parent function is like x squared. I usually like to use him. Okay. Let's say we're going up 6 and down, you might have to pause this, down 2 and right 3 and left 5. And vertically stretch by 7, and vertically compress by, I'm going to write all the rules down, 1/2, and horizontally stretch by 3, and horizontally compress by 1/4, and then I'm going to go over the x-axis, and I'm going to go over the y-axis. Okay, so I'm going to write all these rules down over here to the side, and then you'll have like a little cheat sheet. Okay, so I'll give you a second if you need to pause. If you need longer time to write those down, you just go for it. Okay. All right, so x squared. If I'm moving him up 6 units, that'll just be x squared plus 6. Down 2 would be x squared minus 2. To the right 3. Everything is underneath of the square, and right actually means minus, okay? To the left actually means plus, so this would be x plus 5 squared. So if you want to put a little note over here, opposite sign, right is minus, left is plus. If I'm vertically stretching by 7, I'm just multiplying by 7, so he's just 7x squared. Vertical compression by 1/2, 1/2 x squared. Okay, now here's the tricky part again. Horizontal stretch by 3. He's in parentheses, but if my factor is 3, he's actually 1/3. Okay? If my factor is 1/4, I flip that and he becomes just 4. So these two have a weird thing where you use the reciprocal of the number and when you put it inside. Okay? All right, the other two, if you're going over the x-axis, it's negative x squared. If you're going over the y-axis, it's negative x squared. And technically, this would be just positive x squared because the negative would go away. But that's the rules just with the parent function of x squared. That's how he works, okay? So on 29, again, if you need to pause and write all that down, go for it. But we are horizontally compressing by a factor of 2. Horizontal compression by a factor. That is not right. He should be by a factor of 1/2 because you can't compress by a factor of 2. That's a typo. Horizontally compressed by a factor of 2. We'll say, because something's not right. Either it's a stretch by a factor of 2 or a compression by a factor of 1/2. We'll say 1/2, okay? So what that means is horizontal compression by 1/4 becomes 4x squared, okay? In this case, it's going to become 2, but he's inside of absolute value bars instead. So I have the absolute value of 2x is what he will look like, okay? And then I want to reflect him across the x-axis, which means the negative goes on the outside. So he goes like this, and then shifted 3 units up, so plus 3. So this is what my new function will look like. Oh, they want us to call it g of x. That's what he will look like. And here's my absolute value bars. Those are not like ones. Those are absolute value bars. Okay, so lots of stuff, but here's your cheat sheet over here. It has like all the rules listed, all right? Okay, and then 30 kind of goes with that. It says, what are all these things doing? So here's my x squared. That's my parent function. And then let's figure out how many things are happening, okay? So if I find my x squared, this minus 2 is happening and the 4 is happening. And then we just need to decide which one happens first. So if I were to plug a number in for x, would I subtract 2 or would I multiply by 4? I would subtract 2 first. So I'm going to put that on the outside here. The minus 2 is going to come first, and then the 4 is going to come next. The minus 2 is like this minus 3 here. I'm going to the right 2. And then the 4 is on the outside. That is a vertical stretch by 4. And those are the two things that are happening to number 30. Holy crap, that was a lot. Okay, I'm glad we decided to stop at 30 because that feels like that took forever. All right, so tomorrow's a Friday, which means we have shortened periods. Yes, 7th period we have shortened periods. And basketball leaves, but not till 2:45, so she'd be out of my class. So we've got 15 questions to do. Holy bejeez, that might take a little bit of time. It would not be a bad idea for you to attempt some of these on your own to make it go faster tomorrow. Okay, hopefully you put stars by anything that you don't understand and you can ask me those, and I will hopefully be back tomorrow. I'm gonna be back tomorrow. We'll be there. Okay, goodbye.